Good afternoon, everyone. Thanks for joining me this afternoon. My name is Harpreet Singh. I am the Technical Support Engineer at Solartron Metrology. And today I'll talk about the Wigauge 2, which is the wireless hand tool, generation 1 and 2, and also look at the inductive charger that we have recently introduced. The Wigauge itself, when the word Y stands for wireless, so this is an instrument that can gauge bores on any component wirelessly. So the communication happens via Bluetooth, and the product can communicate with PCs via Bluetooth communication. And the transmission can take up to 15 meters. So the data transmission is up to 15 meters for a class 1 Bluetooth device. But if you're using a class 2 Bluetooth device, the transmission distance can be reduced to 10 meters or less than 10 meters. With the wireless hand tool, you can use any M6 and M10 plugs, and these plugs are very easy to interface with the wireless hand tool, and they are available from most gauge head suppliers like Diatest or Bowers Metrology. The wireless hand tool is a simple to use device, and on the tool itself you have a go, no-go switch which has LED inside it. So every time you press this switch, the signal is sent to the PC that either the part has passed or failed. So it's actually a no-go switch which tells you if the part has passed or not. And it has other uses as well. You can program these buttons to reset, preset, or zero readings as well, which we can talk about later. You can connect multiple Y gauges to a single system. Maximum Y gauges that can be connected to a single system are 7, with one Bluetooth dongle. The IP rating on this device is IP65, but that only applies to the body. It does not apply to the front end where the gauge head is screwed into. And also, the Wigauge has an audio transmission buzzer inside. So every time you press a button to take a reading, to tag a reading, to send it back to PC, the audio transmission indicates the data has been transmitted. It also indicates if the reading taken is under limits or is it outside limits, if it's pass or fail. So the indication will give you that information. So these were the very basic salient features of the Wigauge Generation 1, but my focus on this presentation is the Wigauge Generation 2 and the newly introduced inductive charger. The Wigauge Generation 2 is different from its predecessor by one massive feature, because we have recently introduced an LCD display on this tool. So now the Wigauge has a readout, but it still has all the old features of Generation 1 Wigauge. It's still Bluetooth capable, but now the operator can see the results on the screen. So let's talk about the screen. The Wigauge screen is a similar screen that we have on our ACS display units. It's the same screen, same size. And the resolution available to you on this screen is 0.1 micron resolution, and that is user selectable. So you can select this resolution from the Wireless Hand Tool Manager application. You can display your tolerance values on the display. You can, if you see on the image itself, the bar at the top, the green bar, actually you can see the limit indications. And the color of the bar can also be altered. You can use any color. Well, we have 3 colors, red, yellow, and green, to indicate limits and the reading as well. And the bar at the bottom, the blue bar, it always indicates your absolute reading. So the green bar will indicate your computed reading, but the blue bar will indicate the absolute reading. So that is the functionality of the screen on the Wigauge Generation 2, and that's the only difference there is between the Generation 1 and Generation 2, but they are added features as well. Now let's look at the wireless software. We supply with the Wigauge hardware a utility called Wireless Hand Tool Manager. It's a simple application that can connect to up to 7 Wigauge modules and take data back from these units. This application also allows you to log your readings into Excel format. You can stream readings. You can reset the preset values. You can zero the readings. So all that can be done inside this application. We supply a user manual for .NET drivers with this hand tool, and you can write a custom application using the .NET drivers. Also, it's possible to communicate with the wireless hand tool by sending serial commands. We supply a user manual which can be used to take readings back from the probe by sending serial commands. Right. In the most important feature section, I left out the rechargeable battery feature. The reason being, we have recently introduced new chargers. One is Trickle chargers, the other one is Inductive charger. So I wanted to leave the battery section to the last so we can discuss this in detail. So any wireless device needs a rechargeable battery so that it can operate for lots of long time, for so many hours. With the wireless hand tool, we supply rechargeable batteries, and these rechargeable batteries need to be charged with some sort of device, and we supply our standard chargers. So with every battery charger pack, we supply a smart charger, which is plugged into mains, and it starts charging the battery straight away. It gives us the instant boost, which is about 5 milliamps. And the typical charging time is 2 hours for a smart charger, because we call it smart charger, or you can call it fast charger, because it charges the battery at a very fast rate. And this kind of charger is suitable when you are using the wireless hand tool, offline. When it's offline, when you've done the measurements and you're not using it anymore, it's discharged and you can charge it back up again. But we recommend, I think it's important that you disconnect the battery pack once it's fully charged. It's not recommended to actually leave the battery pack connected for a long time after it's fully charged. Well, the reason being, what happens is, because the smart charger, if you do not disconnect it, it'll keep on supplying the current to the battery, and eventually it will reduce the life of the battery heats up, and it may cause damage. So that's why we introduced a trickle charger. What trickle charger does is, it charges the battery at a very, very slow rate. And this is useful for applications when the tool is left connected. For example, you had long 8-hour shift and the battery is discharged, and the operator plugged the battery in to charge it with the trickle charger, and he can leave the battery connected all night, even the next day, and battery won't heat up, and next day it'll be fully charged, because it charges the battery at a very slow rate, and it doesn't give the battery that instant boost that a smart charger will give. I think smart charger is very useful if you want to charge the battery in a short time, but it's important to disconnect it. Or if you want to leave it connected for a long time, it's best to use the trickle charger. So that was the smart and trickle charger, which are fairly similar. Our latest addition to the charging family is the inductive wireless charger. Inductive wireless charger works on the principle of magnetic resonance. Magnetic resonance means you have 2 coils which transfer electricity from one coil to the other. So for example, in this image, you have see a little cradle, and the wireless hand tool is sitting in the cradle. The cradle itself has a coil inside it, and the battery pack, which is connected to the wireless hand tool, has a coil inside it. So the electrical current actually passes from one coil to the other in a wireless fashion. So that's why we call it wireless charging. Each power supply or each charger that we supply with the inductive charger can charge up to 4 batteries. So you can see in this example, you have one power supply which is charging 4 batteries sitting in 4 different cradles. Well, it takes 14 hours, which is a considerable amount of time to charge the battery from fully discharged to fully charged. But the reason it takes 14 hours is because the charge is limited to 40 milliamps, because this allows the battery to charge at a constant rate without heating up. And the most beneficial aspect of charging the batteries this way or wirelessly is you can charge the batteries in between operations. So for example, if you're taking some measurements on the 50 parts, you did your measurements for half an hour, you put the charger back in the cradle, you charge for half an hour, you can start using again. So you can keep doing this again and again. You can charge battery in between operations. So you do not have to leave it for 8 hours, 10 hours continuously for it to fully charge and then to use it, because it's not connected to any cable. It's sitting inside a cradle. So when you lift up the wireless hand tool, it gets disconnected and you can start using it straight away. But you need to make sure you do not charge the standard battery pack with this inductive charger, because the standard battery pack doesn't have an inductive coil inside. So inductive charger will not charge a standard battery pack. So you can still buy standard battery packs, but they won't be charged with inductive charger. To charge a standard battery pack, you will need either a smart charger, which we see in the previous slide, or you need a trickle charger. Last feature of the inductive charger is it has a mounting holes on the cradles itself, so you can secure the cradles. Because if you ever lifted a wireless hand tool, you know it's considerably heavy, and also if you're going to place the wireless hand tool inside a cradle, you need the cradle to be secure. That's why it has mounting holes to secure it. So that was the wireless hand tool charger and the inductive charger that we have recently introduced. And now let's look at the wireless probe. It's a wireless PCB. It's a PCB that goes inside a Wigauge, and this PCB can connect to any probe. When I say any probe, it could be a block gauge, it could be flexure, it could be a lever probe, a jet probe, a pneumatic spring push standard probe. Pretty much all Solartron probes can connect to this PCB. And this PCB is actually very similar to the Orbit PCB, and it has the same electrical spec. The only difference is this PCB has a Bluetooth antenna that allows for the Bluetooth communication. One last thing I would like to point out, we do not supply any casing or shells with this PCB. Well, the idea is to actually for customer to incorporate this PCB into their application, and they can find a way to secure it. That's why we do not supply any shell or casings.
Thank you for listening.